Hello there everyone. This one is the demo on our project for web text mining on Twitter sentiment analysis, and we have a team of Bharat, Lulin, and Sharmista, and this is Sharmista here. So first things first, an overview of what are we going to see today. We are going to see what's the proposal or the problem today, what is the sentiment analysis, and how does it work for our project, what data we have used, and how did we get the data we need for the analysis, and what are all the algorithms we have used. And we have used more than one algorithm for this experiment or the project, so we are going to compare all the results, and then we are going to conclude on the results of what we have got. Let's talk about the problem. The proposal which we uh, got is from the pandemic which is being prevailed nowadays. So the problem is, as of July 17, 2020, more than 13 million people have been diagnosed with the novel coronavirus, and half of the people have already lost their lives due to infectious disease. Since then, the social media have experienced an exponential rise in content related to this pandemic. In past, Twitter data have been observed to be an indispensable in the extraction of situational awareness information relating to any crisis. So we'll be doing such awareness in situational awareness information thing uh, on COVID data on Twitter. So we what we are doing is we are collecting all the hashtags containing COVID 19 or similar hashtags of COVID 19. We are getting that data, and then we are classifying them and predicting their sentiment, if it's positive sentiment, negative sentiment, or neutral sentiment. We are predicting what sentiment is the user predicting, like expressing over there. Why should people care? Like, in the midst of all the chaos and pandemic we are currently in, how do we measure the global sentiment regarding any particular event? Maybe it's more negative than positive, or maybe more positive than negative. We don't know how people are expressing their feelings. In this way, we can create a sentiment analysis obtained from Twitter tweets to estimate the overall sentiment of a particular event. So, what is sentiment analysis? Sentiment analysis is an automated process to analyze a text and interpret the sentiments behind it. Though machine learning and text analytics algorithms can classify statements as positive, negative, and neutral, this process is also known as opinion mining because it's doing the sentiment. The sentiment is the emotion in the text, so it's called opinion mining, and most of the companies or brands use this as a strategy for social media monitoring to manage large amounts of data and gain customer insights to learn more about customer sentiment and competitions. So for example, if you take any airlines, let's suppose Emirates, they do a really close monitoring on their tweets, or like how well they are doing, like what's the feedback and what are the people are expressing. Suppose if there is any delay in the flight, um, or like it's been half an hour delay in the flight or something, everything, the people are reacting to their tweets over there. They post that this flight is coming, uh, a delayed version of 30 minutes, so they comment on that, and their data analysts, like they do the analysis and they understand how are the people reacting for any of that, and how can they improve further to do their better. So data, we have scraped around 45,000 to 46,000 tweets from Twitter using the consumer key uh, and the tweepy function. So, and what we have done is collecting the data. We have split the data into 80/20, and we have applied the best classifiers to predict the sentiment of new tweet by the user. These are, if we can see here, these are the tweets which are retrieved by us, and they are segregated into different columns. Like all the text goes here, all the usernames goes here, because and location and so on and so forth. We have so many columns, but then any like the most important thing here we need is only text. So we're going to grab all the text, and we are not going to use any of these. I mean, yeah, only the text have been used for this part of analysis. So yeah, once we get the data, we are going to clean the data, and the cleaning process includes removing of punctuations, stemming, lemmatizing. Also we are removing the emojis. Emojis are these characters, they are in the uh, uh, Unicode characters. These are all the emoji characters. We are removing the emojis. Also, if we can see, we are removing the mentions, like if someone mentions someone, that's all irrelevant data for us. So we are removing those. We are removing the retweets, everything, or the hyperlinks, everything here. So around, we got around 45,842 tweets in here, and the unique users here are 34,575 who have tweeted around 45,000 tweets. Sentiment analysis on Twitter. Now we are calculating the subjectivity and polarity of the tweets. Uh, Here, majorly, we are using the text blob library. That's a library in Python which is used to process textual data. And this has two major functions, that is subjectivity and polarity. Polarity, it means the sentiments expressed in a sentence. So we it's a flow, it returns a float value which ranges from -1 to +1, where -1 is a negative statement and +1 is a positive statement, and 0 represents a neutral statement. Subjectivity sentences refer to personal opinion. It also like returns a float value that ranges from 0 to 1, wherein 0 expressing more of a factual information, and 1 is representing the public, like the personal opinion. I'm like, it's the public opinion, it's like opinion, and 0 is the factual information. That's what I meant to say. So if we can see here, like consider the tweet here, San Diego teachers who have refused to open. And there's something more than that. So here what it's saying is the subjectivity is 0 and the polarity is 0, which means it's a neutral, mm, neutral statement with a polarity again, like with a subjectivity again, saying that's the factual information. It's not an opinion, because obviously it says teachers have refused to reopen, so that's a fact which is going on there. Similarly here, the COVID dashboard thing, the COVID being dashboard being updated, which means again it is a factual information inclined towards a neutral sentiment, showing the polarity of 0.13. That's how the sentiment is measured here. Like each one of the state text is given a subjectivity and polarity here. And now we have transformed the numbers which we have got, like zeros, ones, and all of that, to positive, negative, and neutral. And if we can see, here are the clean and like labeled tweets. So this statement is a neutral one, and this one's a positive one. This one's again a neutral one. Sorry, 0 is negative, neutral is 1, and positive is 2. So that's how we have given the function, and each one has been classified into either of these three. And we have also plotted the neutral, positive, and negative tweets here. If we can see, the neutral tweets are around, like carry is the most of the lot. There are more neutral tweets than positive or negative here. Again, here we are using NLTK corpus of stop words to remove the stop words in all of the tweets. And then again, we are pushing that into a clean tweet set. And here we are using a count vectorizer. The count vectorizer, it provides, like it tokenizes the words into our documents, and it builds a vocabulary of known words. This is a feature in sklearn. It also converts a collection of text documents to a matrix of token counts. If we can see, there are like 20,000 different individual words in our corpus right now. That's the matrix here. So, these are the algorithms used for sentiment analysis. We are going to use naive Bayes. Naive Bayes is a popular algorithm for classifying text. Although it's fairly simple, it's based on the Bayes algorithm of statistics, and it has a simple assumption which is making it a naive Bayes. And then we are doing an SVM, support vector machine. It is also a learning technique that performs well on sentiment classification. The performance of SVM depends on the kernel function we use, so we have to use a proper suitable kernel to get the best out of it. And then we have the TF-IDF factorization, which is term frequency inverse document frequency. And for each of the tweet, we are calculating term frequency and IDF, and then measuring the and then predicting the sentiments over here. And then we have a random forest model. It is a type of supervised machine learning algorithm based on ensemble learning. It Ensemble learning is a type of learning where you join different types of algorithms or the same algorithms multiple times to form a more predictive prediction model. And then finally we have decision tree classifier, which are used successfully in many diverse areas. The most important feature is the capability of capturing descriptive decision making knowledge from the supplied text or data. Decision tree can be generated from the training sets. So now we are going to see how much each algorithm has predicted, what's the accuracy of all of those. So first, what we are it the process is similar for all the models. We are going to first split the data into an 80-20 basis using the train test split function, and then we are predicting the sentiment of the tweets. So if we have split the data now, and now we are using a multinomial naive Bayes function over here. So and then we are applying it on the training set, the classifier we are applying on the training set, and now we are trying to predict it on the test set. After it has been done, we are doing a confusion matrix, and also we are creating a classification report. This classification report is like a text report showing the main classification matrices. This classification report has many features over here. Let's have a brief glance of what each one does here. So the precision is a measure of relevancy, like how much relatively it's giving the value. And recall is the measure of how many true relevant results are retrieved. And F1 score is the weighted average of precision and recall, where F1 score reaches its best at 1 and worst at 0. Support it is the number of occurrences of each class. Here the class is negative, neutral, and positive. Out of each class, how the number of occurrences are coming, like, and that of sorry the support, it is the number of occurrences of each of the classes here of the y predict variable. Also we have accuracy, which is the model which is how well the model predicted the data. And macro averages are the unweighted averages. Also we have the weighted averages over here. So if we can see, it has almost predicted the negative values. 0.75 is the precision over here. Like, it has done a 75% correct prediction over here. It has done a 90% correct thing over on neutral tweets. It has done 0.83 precision, like 8.3 times of 100. It has predicted correctly that it is a positive tweet. That's how the precision here works. And also if we can see, the accuracy is 0.84. So we got an accuracy of 0.84. And the coefficient of determination, it's a stat term. Like, it represents the proportion of variance of white test over here, white test. And that has been explained by independent variables in the model. It varies from 0 to 1, whereas 0 having the worst and 1 having the best. So we have got around 0.47 for naive Bayes, which is like in the mediocre result. Now we have SVM having an accuracy, like we have used the similar method. We have a function for SVM in sklearn. So we have used that and we have brought a classification report here. And we have got an accuracy of 0.85 along with a coefficient of determination of 0.44. Again, it's almost similar to naive Bayes what we have got. And now it is TF-IDF. Here the accuracy is 0.95 and the coefficient of determination is 0.83. This is like way far on the good side, on the positive side of the scale, the whereas the other two were on the mediocre side of the scale. Now we have the random forest. The accuracy is again 0.94. I'm so sorry. The accuracy is again 0.94 and the coefficient of determination here is 0.79, which is again a good model according to what we can see here. And the decision tree has an accuracy of 0.92 and the coefficient of determination of 0.70. Again, one of the best model, best classifier, I'm so sorry. So here if we can see, this is the model comparison of all the five algorithms we have used, the accuracies and coefficient of determination. So we want the best of both of them, and so we thought TF-IDF is the best model where we can where it's doing a great job with accuracy and the coefficient of determination over here. What is really original about this? So we are predicting whenever a new tweet comes, and we are classifying if it's positive, negative, or neutral, based on the text or data. And our data's so if we have seen, we have 95% accurate, we are 95% accurate of the model here, and we have used various models to train our data sets. Some algorithms show greater accuracy and some do not. Companies and government agencies can get an idea how people are taking the COVID situation and take the necessary measures. For example, a government agency can know how people are reacting to this new strain, what all challenges they are facing, such as food scarcity, panic attacks, etc. And now that we have COVID vaccine too, based on that tweets, also we can understand how people are reacting towards vaccine, how many are taking, how many are getting vaccinated, how well the youth is reacting to that, all of that. And also in this panic situation, how the non-profit organizations can help to the people. All of that can be analyzed, like they can understand, like basing on how people are reacting. Sentiment analysis, and finally, on the conclusion, sentiment analysis is an application of NLP to identify and extract subjective information from a piece of text. Information related to a piece of text involves feelings such as positive, negative, joy, happiness, fear, everything. This is particularly useful for giving people an overall feel of what is being talked about or tweeted about on a particular topic like COVID 19 in this situation. The purpose of our project is to classify the data we scraped from the Twitter and predict them according to the sentiment through our clean data. When we predict salary, uh, when we predicted the tweets, we used five algorithms as we discussed: naive Bayes, SVM, TF-IDF, random forest, and decision tree. Finally, we concluded that TF-IDF is the best performer among all of that. So, these are the works or the websites we have used for creating this project and working on the models. And thank you.